Welcome back to a very quick, a bit of a side video to the dot particle optimizations the other day. It occurred to me that since we're talking about, or I'm testing 165 all the time, if you've been along for the ride, you probably don't really notice the changes as we progress. So I thought, well, let's test this particle demonstration in the Learning Edition. Now we're talking about the same hardware here, and I'll have to cut this video a bit to condense it. But let's try now with, we'll refresh ourselves with pretty much the naive version of the particle test and the fastest version. Okay, we've got, as by magic, we're running PB165, whatever this current build is on my laptop. Let's try the first version, which is the naive version of the application. Let's run it, see how she goes. Put our mouse about there in the center. Oh, we fixed a logic bug here that apparently it bugged Dan so much. I did notice it later on, but I thought, well, I'll leave the code I'm posting be the same as the one that was in the video, otherwise people get a bit dodgy about those things. Alright, so on this test here we're running about somewhere in between, I'll be generous and say about 9 to 10 frames per second. Now this is in 165C2. We're running what? 85,000-ish particles. Let's refresh ourselves. Let's go and see. This is the fifth example too. It uses groups. You can take this idea here further, but this wasn't in the other version of the demo. Give it a go. So we're capturing the screen. We're pretty much getting a nice comfortable sort of high 20s to 30 frames per second. Pretty cool. Again in 165. Hit escape to get out of that one. Now, by the magic of editing, I'll close this down. Okay, as if by magic, we've loaded PlayBASIC V164. It's the Learning Edition. And we'll try the first example in this version. See what difference we actually get. I think you can tell there's a big difference in performance. So in 165 it's clocking about, and we were kind of generous before, we're saying about 9 frames per second, around that sort of thing, for our 85,000 particles, and now we're down to 1 or 2 frames per second. Big difference in processing ability. So here our estimated particles per second is about 160,000 particles. I think really we're running down about 1 frame a second. So these changes to the runtimes, they make a big difference. And if I went back, although I don't have it on this computer, if we went back to older versions and went all the way back to like the first releases, it would run, comparing those releases to the Learning Edition, would be the same kind of performance gap again. Alright, that's pretty sad. So we'll try the quicker one. I'm not that. This is example 5. This is the most optimized version of this rotator that I included. it uses grouping, this one, so it rather than have one big list of particles, it groups the particles that were created on the same frame together and manages their acceleration under gravity globally, which gets rid of a handful of calculations per particle. Anyway, let's try this in the free version, see how we go. Well, it's running much better. That's pretty good, actually. I'm actually impressed by that. I wasn't expecting it to run that well. So what would you say? I would say that our updates have probably doubled their performance between the Learning Edition and the current build of 165. And all you've had to do is just update. Sounds reasonable to me. Some of the other versions they won't build, I know, that because there are commands that are different. But this last one works the same way. You don't have to change anything for it to work in both versions at all. I'll show you what I mean. Alright, type caching with pointers. Let's try that one there. See if we compiles. Well, that one compiles, that's alright. So it still works, just that it's much slower. 1 frame a second. Not much fun. Let's try the second build of that. The second, just type caching. I think these use getArray pointer, and that was changed at some point. I'll soon find out. Yeah, that's right. So these don't compile out of the box because of this parameter here, although it's blocking it off for us now. This second parameter here was only added in more recent builds of PB. What it does is if you go to the help, is it emulates this process here. So if we get a pointer to an array, it'll give you the very first byte of this chunk of memory. Now that arrays have a header on top of them, which is not your data, it's information about how this array is laid out in that block of memory. And here I'm telling PB to return a pointer but skip over that header. So in old versions it didn't do this. And there was a structure offset here, which is an internal constant. Now that constant's different between different builds of PB, so you should never use a fixed literal value. You always would use the constant. What you would do is do this. I'll try and get it to work. So we take that out. We just add this offset onto it. Oh, got a carriage return. I picked it up from the text. I'll grab that. I think we grab another pointer at some other point in this one. No pun intended. Yeah, we do. So I'll get rid of that. Add that on. Let's try again. Okay, so we got it working just by changing that command. So a lot of those things will happen if you're using an old version trying to run newer code that was written for newer versions of PB. You run into functions that don't exist in your old version. Wow, it's really, the free version is really choking on this sort of naive approach. But I didn't mind revision 5, so that's pretty good. Example 1, where are we? Example 5 in the Learning Edition. Let's run again. I'm pretty happy with that, actually. I don't know how old this Learning Edition build actually is. It's probably 10 years old, but the runtime is pretty reasonable. You've obviously got to use it within the right constraints. But like that's the same for most things. It's still much slower than 165. This demo without screen capturing runs about 35 to 30, sort of almost 40 frames per second on my laptop. But you know, that's just what happens. Well, that completes that. So thanks for watching, and hope you're having fun at whatever you're doing, and we'll see you next time. Bye.